The second part of this lesson has to do with another common right triangle, which is a 30, 60, 90 triangle. We're going to look at that right now. In this case, they're talking about an equilateral triangle with side lengths of 6. So I'm going to draw that. Now remember, if it's an equilateral triangle, that means that each of the angles is equal to 60. What we want to do, since we want to know what the height of the triangle is, I'm going to draw a line going straight down here. And that's not a perfect equilateral triangle, but we'll use it. We know that this is 60 degrees. We know that this is 60 degrees. We know that this, since this cuts this in half, this is going to be 30 degrees. And that's also going to be 30 degrees. And these two triangles should be congruent as well. Now, if this is 6 centimeters, this is also 6 centimeters because it's equilateral. And down here, these two should be 3 centimeters. And what we want to know is this height right here. We really only need one of these two triangles. Now, hopefully in your notes you've seen that if I have a 30, 60, 90 triangle, and I'll draw one right here. Assume that's 30, 60, 90, where this is 60 and this is 30. What you need to remember is that the shortest side and the hypotenuse have a 2-to-1 ratio. So this is x right here, and this is 2x right here. And then the third side will have this as its length. Now, why is that true? Well, first of all, you can see right here that this is going to be half of what this is, or this is twice what that is. So that's pretty obvious right there. Just in a equilateral triangle, we can see that the distance is twice as big there. So what we can do is say, if this exists, what's the third side? So the hypotenuse is 2x squared, and we're going to find, we'll call this b for right now. We'll say b squared plus x squared, because that's this side right here. And we want to solve for b. So here we get 4x squared equals b squared plus x squared. If I subtract x squared from both sides, we get b squared is equal to 3x squared. And taking a square root of both sides, I'm going to put the result down here. We get b is equal to, again, the squared comes out as x, and we have the rad 3 left over. So there's our x rad 3. Going back to this problem, we know this is this length right here is our 2x, and this is our x. So again, I'm going to do this in a different color just so we can see. So this is our 2x, this is our x, and this is our x rad 3. In that case, if x is equal to 3, then x rad 3, if x is equal to 3, and 2x is equal to 2 times 3, or 6, then x rad 3 should be 3 rad 3. Hopefully you can see that. Again, x equals 3, so we plug the 3 in here and we get 3 rad 3 for our height. So our height is equal to 3 rad 3 centimeters. Okay? Let me change this back. So again, this is just what I showed you. We have a 2x and an x here, and that's what we want to find. So we know that the longer leg is equal to the shorter leg times rad 3. So it's 3 rad 3, or approximately 5.2 centimeters. Here's another one. And this one is, again, sort of like the last problem I showed you in the last video. If we look carefully at this, this is our 2x, this is our x, and this is our x rad 3. So we can say that x rad 3 is equal to 9 here. If x rad 3 is equal to 9, then dividing both sides by rad 3, we get x is equal to 9 over rad 3, or multiplying top and bottom by rad 3, because remember we have to rationalize the denominator, we get 9 rad 3 over 3, which reduces, if we change this to a 1 and this to a 3, to 3 rad 3. That means that this distance right here is 3 rad 3. Now we know that this is twice as big, so y is going to be equal to 2 times 3 rad 3. Okay? Again, we know x rad 3 is equal to 9, so we solve that and we got 3 rad 3. So that means that this short leg is 3 rad 3. The long leg is twice as big, so it's going to be 2 times 3 rad 3, which is 6 rad 3. Okay? So we found the value of x by doing this. Divide both sides by rad 3. Multiply top and bottom by rad 3 there. And we get 9 rad 3 over 3, or 3 rad 3. To find y, we just double it, and we get 6 rad 3. Here's another one. This time, the short leg here is x, this is 2x, and this is x rad 3. And I'm sorry, maybe I should use a different letter since we're solving for x there. Let's call this a, let's call this 2a, let's call this a rad 3. So we know that a is equal to rad 3, and we want to find this part right here, so we really want to find a rad 3, because that's what x is. So a rad 3, we're going to take this rad 3 and plug it in there. We get rad 3 times rad 3, which gives us rad 3 times rad 3 is 3. So our answer there is 3. And if we wanted this, just if we wanted it, it would be 2 times rad 3. Because if this is rad 3, that's twice as big. Okay. Here's another one. Again, assume this is an equal, well, you don't have to assume. This is 4, and those are both 4. So again, let's call this my 2a, because it's my hypotenuse. This is my a, and this is my a rad 3. So h is really the a rad 3 side, and since a is equal to 2, we know this is 2 rad 3. And here's another one where we've got the body of a dump truck is raised to empty a load of sand. How high is the 14-foot body from the frame when it is tipped at the given angle? So the given angle is a 45-degree angle. If we look at this carefully, we'll do 45 and 60. So if we look, we would assume this is the 90-degree angle here, and if it's 45 degrees and that's 14, then this is also 14. And what do we want? Oh, we want to know what that is right there, it looks like. So, okay, so if this is 14 right here, then we want to know what this distance is, straight up and down, because we're assuming those are equal when it's 45 degrees here. Okay, so if that's 14, basically what we have is we have a triangle that looks like this, where this is 14 feet. And we want to know what that is, which is also that for part A. Remember, this is the x rad 2 side, so we would say x rad 2 is equal to 14, dividing both sides by rad 2. We would get x equals 14 over rad 2, and hopefully you can make a shortcut on this after a while. But multiplying top and bottom by rad 2, we get 14 rad 2 over 2, which is 7 rad 2, sorry. And that would be 7 rad 2 feet. And you could calculate that in terms of the number as well. We won't worry about that right now. The second one is telling us if this angle is no longer 45, but it's 60 degrees. So basically we have something where it looks like, not drawn very well, but that's okay. This is 60 degrees now, and this is still 14 feet. Okay? So in this case, we've got x down here, we've got x rad 3 over here, and we've got 2x here. So we want to know what that height is. We know that 2x is equal to 14 if we divide both sides by 2. We now know that x is equal to 7 feet, so down here it's 7 feet, but we want to know what the height is, so that's going to be x rad 3. If we take the x and we plug it in there, that's going to be 7 rad 3 feet. Okay? And again, you'd calculate what that really is. So there's the 45, 45, 90. Again, we solve for h here, and we get approximately 9.9, which would have been 7 rad 2. And for the second one, picture looks like this now, where that's 60 degrees, and we want to know this height, where the hypotenuse is 14. So again, we know that 2 times this bottom part will be 14. Therefore, this bottom part is 7. And since this times rad 3 is the height here, we would plug that in and we'd get 7 rad 3 there. So calculating that, that would be about 12.1. Okay? Alright. And then it said, what if it was 30 degrees? Well, that would change the problem a little bit. We would have this be 30 degrees, and this would still be 14 feet. And again, remember, this is 2a, this is a, and this is a rad 3. This is actually an easier problem because we would know that 2a equals 14. Therefore, dividing both sides by 2, we would know a, which is really our height, is 7 feet. Okay? Cool. Okay, in this section we're looking at describe the location of the shorter side. Triangles. In other words, we have 2 angles. Describe the location of the longer side. So this is also the shorter side is adjacent to the 60-degree angle, and the longer side is adjacent to the 30-degree angle. Remember, if these 2 angles are just congruent, so that you know what they're saying. That means that these 2 sides are also congruent, and hopefully you learned that. So here's the 60-degree. Here's the like this 30-degree. These 2 sides are equal. And what they're saying is that the shorter side is right next to these are both x, the 60-degree angle, be x and the longer side is right next to the 30-degree angle. Basically, if we know these 2 sides are equal, and we're done. We could call this